Have you ever looked at a picture of a volcano erupting and just wondered, how does the Earth, this solid ground beneath our feet, suddenly burst open with molten rock and ash? It's one of nature's most spectacular and powerful displays. And today, we're going to peel back the layers of our planet to understand exactly what causes volcanoes to form and erupt. So, let's start with the basics. Deep beneath the surface, the Earth is incredibly hot. So hot, in fact, that rock can melt. This molten rock is called magma because magma is hotter and less dense than the solid rock surrounding it. It wants to rise, kind of like a hot air balloon floating up through the cooler air. As it rises, it collects in large underground pools called magma chambers. Now, this is where things get interesting. A volcano is essentially just an opening, or a vent, in the Earth's crust that allows this magma, along with gases and ash, to escape to the surface. But why do these vents form in the first place? It mostly comes down to something called plate tectonics. You can think of the Earth's outer shell, the crust, as a giant jigsaw puzzle made of massive pieces called tectonic plates. These plates are constantly, slowly moving around, bumping into each other, pulling apart, and sliding past one another. The vast majority of volcanoes on Earth are found where these plates meet, at the plate boundaries. Let's look at the first and most common type of boundary: convergent boundaries. This is where two plates collide. Often, a denser oceanic plate will slide underneath a lighter continental plate. This process is called subduction, as the oceanic plate dives deeper into the Earth's mantle. The incredible heat and pressure cause the rock to melt. This new magma is buoyant and rises up through the continental plate above it. Eventually, it can break through the surface, creating a volcano. The famous ring of fire that circles the Pacific Ocean is packed with volcanoes formed this way. Think of the Andes Mountains in South America or Mount Fuji in Japan. These are classic examples of subduction zone volcanoes. Sometimes two oceanic plates can collide. One will subduct beneath the other, and the resulting volcanism creates a chain of volcanic islands known as an island arc. The beautiful islands of Japan and the Philippines are perfect examples of this process in action. Next up, we have divergent boundaries. This is the complete opposite of a collision. Here, two tectonic plates are pulling away from each other. As they pull apart, the pressure on the underlying mantle is reduced. This reduction in pressure lowers the melting point of the rock, allowing it to melt and turn into magma. This magma then rises up to fill the gap, often creating new crust on the ocean floor. This process is happening right now along the Mid-Atlantic Ridge, where a massive underwater mountain range of volcanoes is constantly, quietly erupting, slowly pushing the Americas and Europe further apart. Occasionally, this rifting can happen on land, like in the East African Rift Valley, creating a line of volcanoes as the continent begins to tear itself apart. So we have plates colliding and plates pulling apart. But what about the volcanoes that seem to pop up in the middle of a tectonic plate, far away from any boundary? Hawaii is the most famous example of this. It's sitting right in the middle of the Pacific Plate. So what's going on there? This is where our third cause comes in. Hotspots. A hotspot is a fixed spot deep within the Earth's mantle that is unusually hot. Think of it like a giant blowtorch from the Earth's core pointing up at the crust. This intense heat melts the rock above it, creating a plume of magma that rises and punches through the plate to form a volcano. Now, here's the cool part. The hotspot itself stays in one place, but the tectonic plate keeps moving over it. As the plate drifts, the hotspot creates a new volcano, and the old one, now cut off from its magma source, becomes extinct and erodes away over millions of years. This creates a long chain of volcanoes, with the only active one being the one currently sitting over the hotspot. The Hawaiian Islands are a perfect, beautiful chain created by the Pacific Plate moving over the Hawaiian hotspot. The Big Island is the youngest and most active, while the islands get progressively older as you move northwest along the chain. So, to recap the three main drivers of volcanism, you have subduction at convergent boundaries, where one plate dives under another. You have rifting at divergent boundaries, where plates pull apart, and you have hotspots, these mysterious plumes of superheated rock rising from deep within the mantle. But what actually triggers an eruption? Inside a magma chamber, it's not just molten rock. There are also dissolved gases, like water vapor and carbon dioxide, trapped under immense pressure. It's like a giant unopened bottle of soda. As more magma rises into the chamber from below, the pressure builds and builds. If the pressure becomes too great for the surrounding rock to contain, or if a crack or weakness develops in the crust above, it's like shaking that soda bottle and then popping the cap. The dissolved gases suddenly expand into bubbles, drastically decreasing the magma's density and propelling it with explosive force up through the vent. This is what creates those powerful, dramatic eruptions we see with plumes of ash soaring miles into the sky. In other cases, if the magma has fewer dissolved gases and is less viscous, it can flow out more gently, creating the slow-moving rivers of lava you see in places like Hawaii. From the violent collisions of tectonic plates to the silent, steady burn of a mantle hotspot. The causes of volcanoes are a direct window into the powerful and dynamic forces at work deep inside our planet. They are not just destructive forces, they are also creative ones, building new land and shaping the very world we live on. It's a constant reminder that the ground beneath us is alive and always changing. So the next time you see a volcano, whether in a picture or from a safe distance, you'll know the incredible geological story that led to its creation. Thanks for joining us on this deep dive into the Earth. I hope you found it as fascinating as I do. If you enjoyed this video and want to learn more about the amazing world we live in, make sure to hit that like button and subscribe to the channel. Let us know in the comments what other geological wonders you'd like us to explore next. See you in the next video.